E-Chemistry class, Fatima Convent High School. Myself, Dipali. Chapter 5, Periodic Classification of Elements, Part 1. We are going to understand what is periodic classification of elements. We know that the substances in nature are classified into two broad classes as pure and impure substances. Now, pure substances are again further classified. Substances are of two types, pure substances and impure substances, and these pure substances are further classified as elements and compounds, and impure substances are called mixtures, about which we have studied in 9th standard. Now we are going to talk about elements in this chapter. These elements are again grouped into various classes according to their certain properties taken into consideration. Till date, 118 elements are found on Earth, and out of this, 94 are naturally occurring. Rest all are synthetically made. Now, there were various scientists who worked over the classification of these elements so that the studying of these elements becomes very easy and simple. Let us have a look over it. In class 9, we have learned that matter around us is present in the form of elements, compounds and mixtures, and the elements contains atoms of only one type. Do you know how many elements are known till date? At present, 118 elements are known to us. All these have different properties. Out of these 118, only 94 are naturally occurring. As different elements were being discovered, scientists gathered more and more information about properties of these elements. They found it difficult to organize all what was known about the elements. So, they started looking for some pattern in their properties on the basis of which they could study such a large number of elements with ease. This is the reason why the classification was made. So, making order out of chaos, early attempts at the classification of elements were done by many scientists, out of which Daubenier was first. We have been learning about how various things or living beings can be classified on the basis of their properties. Even in other situations, we come across instances of organization based on some properties. For example, in a shop, soaps are kept together at one place while biscuits are kept together elsewhere. Even among soaps, bathing soaps are stacked separately from washing soaps. Similarly, scientists made several attempts to classify elements according to their properties and obtained an orderly arrangement out of chaos. The earliest attempt to classify the elements resulted in grouping the then known elements as metals and non-metals according to their properties. We all know what are metals and what are non-metals. Later, further classifications were tried out as our knowledge of elements and their properties increased. Imagine that you and your friend have found pieces of an old map to reach a treasure. Would it be easy or chaotic to find the way to the treasure? Similarly, chaos was there in chemistry as elements were known, but there was no clue as to how to classify and study about them. Now, scientist Daubenier in the year 1817, whose full name is Johann Wolfgang Daubenier, a German chemist, tried to arrange these elements with similar properties into groups. The chemical and physical properties were taken into consideration. He identified some groups having 3 elements each, so he called these groups triads. Dobenier showed that when these 3 elements in triads are written in order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. So, very simple. Suppose atomic mass of some element X is A and of element Y is B. Then he added these 2 masses and he divided by 2 and he got some answer C, which was the mass of element Z. So he arranged as X, Z, Y as the triad or the groups of 3 elements each time. So for example, take the triad containing of lithium, sodium and potassium with the respective atomic masses of 6.9, 23.0 and 39.0. What is the average of atomic masses of lithium and potassium? If you try to add, you get 6.9 plus 39.0, you get 9.51, that is 45.9, which is approximated to 46 divided by 2, you get 23, which is the atomic mass of sodium. So this is how you can calculate according to Dobenier's triad. Now given below are groups of 3 elements. These elements are arranged downwards in order of increasing atomic masses. Can you find which group? You will observe that in group A, the total of 14 plus 74 is not equal to, divide by 2 is not equal to 31. So this is not forming a triad. Whereas if you add 40.1 and 137.3 and divide by 2, you get 87.6. So this is a triad. Similarly 35.5 plus 126.9, when you add and divide by 2, you get 79.9. So this is a triad. So you will find that the groups B and C form Dobenier's triad. Dobeniers could identify only 3 triad from the elements known at that time, and hence this system of classification into triad was not found to be useful. These are the limitations of Dobenier's triad. John Wolfgang Dobenier, 1780 to 1849. John Wolfgang Dobenier studied as a pharmacist at Munichburg in Germany and then studied chemistry at Strassburg. Eventually, he became a professor of chemistry and pharmacy at the University of Jena. Dobenier made the first observation on platinum as a catalyst and discovered similar triads of elements which led to the development of periodic tables of element. This was his contribution to chemistry. Here are the 3 Dobenier's triad given to us, where you have lithium, sodium, potassium, calcium, strontium, barium and chlorine, bromine and iodine. But he couldn't find anything more than this due to the limitations he faced while classifying them further. Now let us see contribution of one more scientist called Newland's law of octaves. The attempt of Dobeniers encouraged other chemists to correlate the properties of elements with their atomic masses. In 1866, John Newlands, an English scientist, arranged the then known element in the order of increasing atomic masses. He started with the elements having the lowest atomic mass, hydrogen, and ended at thorium, which was the 56th element that time found. He found that every 8th element had properties similar to that of first. So he could group them into octaves or groups of 8. He compared this to the octaves found in music. There he called it as the law of octaves. So other than Dobenier, Newland classified or made groups of 8 elements. It is known as Newland's law of octaves. In Newland's octave, the property of lithium and sodium are found to be same. Sodium is the eighth element after lithium. Similarly, beryllium and magnesium resemble each other. So you can see the pairs which can be asked: beryllium and magnesium, lithium and sodium. The part of the original form of Newland's octave is given in the table. Now you can observe here, if you see, the musical notes in Hindi is sa, re, ga, ma, pa, da, ni, and in English do, re, ni, mi, fa, so, la, ti. So according to that, he grouped them as hydrogen, lithium, beryllium, boron, carbon, nitrogen and oxygen. Then you have fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur. So like that way you can see how the groups were formed. Are you familiar with the musical notes? In the Indian system of music, there are 7 musical notes in the scale sa, re, ga, ma, pa, da, ni. In the West, they are do, re, mi, fa, sol, la, ti. The notes in a scale are separated by whole and half step frequency intervals of tones and semitones. A musician uses these notes for composing the music of a song. Naturally, there must be some repetitions of notes. Every eighth note is similar to the first one, and it is the first note of the next scale. So it was found that the law of octave was applicable only up to calcium. Now these are the limitations of Newland. Was applicable only up to calcium, as after calcium every eighth element did not possess the property similar to that of first. It was assumed by Newland that only 56 elements existed in nature and not more would be discovered in future. But later on several new elements were discovered whose property did not fit into law of octave. So this is again the second limitations of Newland's periodic table. In order to fit elements into this table, Newland adjusted 2 elements in the same slot but also put some unlike elements under the same notes. So you can find examples in the table as here, where cobalt and nickel are put together, and here as well. So you can see that cobalt and nickel are in the same slot and they are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Iron, which resembles cobalt and nickel in the property, has been placed far away from these elements. With the discovery of Nobel gases, the law of octave became completely irrelevant. Thus, Newland's law of octave worked well with lighter elements only. After that, it couldn't function any further. Next, we are going to study the Mendeleev's periodic table and modern periodic table, which is based on Mendeleev's periodic table, which was accepted to a larger extent than the other two periodic tables. Thank you.